Spectral behavior of surface features. Yes, EMR incidence on Earth's surface behavior of land feature is mainly due to the component of the target of that locality. Since each of these components exhibited a typical spectral signature influenced by so many other parameters of their own, they are to be considered separately to understand the nature of EMR interaction with each component's spectral signature or water, vegetation, and soil are discussed below. Spectral reflections and signature of soil. The majority of the flux incident on a soil surface is reflected or observed and little is transmitted. The reflection properties of the majority of soils are similar, with a positive relationship between reflex and wavelength, as seen in Fig 3.7. Main factor influence the soil reflections in remote sensing images and mineral composition, moisture content, organic matter content and soil structure and iron oxide content. Size and shape of the soil aggregate also influence the reflections in the images. Effect of mineral composition. The mineral composition of soil affects the reflection spectrum. Increasing reflections of soil across from the visible to the short wave infrared, with absorption bands around 1.4 nanometer and 1.9 nanometer related to the amount of moisture in the soil. Affected of soil structure and moisture. The relationship between structure and soil moisture can best be described with reference to considering soil type. A clay soil tends to have strong structure, which leads to rough surface texture, and have high moisture content, and as a result have a fairly low diffuse reflections. In contrast, a sandy soil tends to have a weak structure, which leads to a smooth surface texture, and have low moisture content, and as a result a fairly high and often specular reflections properties. Soil structure also affected soil optical properties. In visible wavelength, the presence of soil moisture considerably reduced the surface reflections of soil. Until the soil is standard, reflections in near and middle infrared wavelength is also negatively related to soil moisture. An increase in soil moisture will result in a rapid decreases in reflections in water and hydroxyl absorbing wave bands. The effect of water and hydroxyl absorption is more noticeable in clay soil as it has much bond water and very strong hydroxyl absorption properties. Effect of organic matter. Organic matter may indirectly affect the spectral influence based on the soil structure and water retention capacity. It is dark and its presence decreases the reflections from the soil up to an organic matter content of around 4 to 5%, but beyond it hardly affects. Effects of iron oxide. Iron oxide gives many soils the resultant coloration. Iron oxide selectively reflects and red light. Effect of size and shape. Soil aggregate size and shape influence the reflections properties. If the size of a soil aggregate large in diameter, a decrease in reflection will result. Spectral reflection and signature of vegetation. Components that involve in classification vegetation from remote sensing images received from satellite include chemical properties and physical properties recorded for the vegetation. There are several factors that influence the reflections quality of vegetation and satellite, and remote sensing images. Those include brightness, greenness, and moisture. Brightness is calculated is a weighted sum of all the band and is defined in the direction of principal variation in soil reflections. Greenness is orthogonal to brightness and is a contrast between the near infrared and visible band. It is related to the amount of green vegetation in the scene. Moisture in vegetation will reflect more energy than dry vegetation. Leaf properties that influence the leaf optical properties, the internal or external structure, age, water status, mineral stress, and the health of the leaf. It is important to note that the reflections of the optical properties of leaf are the same regardless of this basis. What may differ for each leaf is the typical spectral feature recorded for the three main optical spectral domains: leaf pigments, cell structure, and water content. Electromagnetic wavelength affect different parts of plant and trees. The spot includes leaf stem, stalks, and limbs of the plants and trees. The length of the wavelength also plays a role in the amount of reflection that occurs. Trees, leaves, and crop canopies reflect more in the shorter radar wavelengths, while tree trunks and limbs reflected more in the longer wavelength. The density of the tree or plant canopy will affect the scattering of the wavelength. Within the electromagnetic spectrum band will produce different levels of reference rates. For example, in the visible band, 400 to 700 nanometer, a lower reflections will occur as more light will be absorbed by the leaf pigments than reflected. The blue and red wavelengths include two main absorption bands that absorb two main leaf pigments. The image created by remote sensing will be influenced by those factors: quality, scale, and season of photography, film type and background. Other factors that influence vegetation classification are time of day, sun angle, atmosphere has, clouds, processing errors of transparencies, prints, and errors in interpreting the images. Photographic structures, total context or color, relative size of grown image at given photo scale, and topographic location helps to determine the cover type of vegetation. Different type of image will display diverse characteristics of vegetation. Satellite image can be combined with topographical data for better interpretation. Spectral reflections and signatures of water. The majority of radiation flux incident upon water is not reflected but it either observed or transmitted. In visible wavelength of EMR, little light is observed, a small amount, usually below 5%, is reflected and the rest is transmitted. Wavelength in the blue-green portion of the spectrum will have a high transmission rate. The most distinctive characteristic of water with reference to spectral reflex is the imagery energy observation at the near infrared wavelength. Water absorbs infrared strongly, having little radiations to be either reflected or transmitted. These result in safe construct between any water and land boundaries. The factors which govern the visibility in reflections of a water body are the depth of the water, suspended material within the water, and surface roughness of the water. Energy is absorbed by water in wavelength. The wavelength will interact in the complex manner with the water and matter. The reflections properties of water are a function of the water and the material in the water. In shallow water, some of the radiation is reflected not by the water itself but from the bottom of the water body. Therefore, in shallow strip, it is often the underlying material that determines the water body's reflections, properties, and color in the FCC. If the water has a large amount of suspended sediment present, then a higher visible reflections will result compared to clear waters. Turbulent water will also affect the amount of energy observed and transmitted. That amount of chlorophyll will also affect the amount of water reflections. An increase in chlorophyll will result in decrease of blue wavelength and increase in green wavelengths. Water bodies that contain very high amount of chlorophyll have reflections properties and resemble, at least in part, those of vegetation with increased green and decreased blue and decreased red reflections. Temperature variations also affect the reflections of water throughout the day. The roughness of water surface can also affect its reflection property if the surface is more than light is reflected, giving very high or very low reflections dependent upon the location of the sensor. If the surface is very rough, then there will be increased scattering at the surface, which in turn will increase the reflections.